Hello and welcome back to Codeblaze, and continuing on with the series creating voxel chunks in Unity using the job system and burst compiler. So in the last episode we created cubes, so just a single cube actually. So if I just play the game, and you'll see we are programmatically creating a cube using the cube component that we created, and there it is. So in this episode, we'll be diving into the job system. We'll be jobifying the basic cube creation code. You won't have any performance gains while creating a single cube here in this actual case, but this would form the basics of actually how job system can be used in some real scenario. And this would also be the basis of how we'll be creating voxel chunks we'll just be modifying this job only. So back in our code editor, we'll open our scripts folder. Inside cube, we'll create a new struct, and this will be a struct. We'll call it cube job. So I assume you have some basic idea of what the job system is and like some theoretical overview of it, because I'll be mostly focusing on the implementation side. So for a simple introduction, job system is kind of the new way Unity is trying to tackle multi-threading. So with this, you'll be able to create simple functional jobs that you can schedule. So all of scheduling and handling is done by the job system. But there are some limitations to it. The job system can only handle buildable types, so that are your int, byte, and all your primitive types. And other than that, there are some native containers provided by Unity that can work with the job system. To create a job, you basically create a struct which extends from iJob or iParallel job, which is a different type of job, which I don't think I'll be covering in this series, but iJob is something that we'll be covering. So if I implement the missing members, we basically get this execute method, and we can do whatever we want here. So the way the job system works is you provide it with some input, and also you declare the outputs that you want, and in the execute method you do your computation on that inputs and populate the outputs, and that's basically how it works. And to do this, I'll be creating a few structures here inside this job only. So we'll call public struct, and this would be mesh data. Now these structs can actually be outside of this thing or could be inside also, it depends. We'll look into that later. So this mesh data structure would be the thing that would be outputted. So this will contain two things: a native list of float 3. Now we can't use vector 3 here since that is a managed type, and this will be vertices, and we can have this as public. We can go with getter setters and whatever you want. Now we'll just create the getter setter only. So we'll have get set. Next we'll have another native list of integers. Integer is a buildable type, so that won't be a problem, and this will be our triangles. Again, we'll have a get and a set. So we have these two properties here, and this is what we'll be populating. So we'll create a public variable here of type mesh data and call that mesh data, and again this will also be a property get set. Okay, and in the execute method we'll basically be populating this mesh data according to the inputs. So for now we are actually not having any specific inputs here other than the position that also we are assuming as vector 3.0. So if we go into our cube code, this function is something that we'll be moving into our job now. Okay, And yeah, instead of vector 3, this will be a float 3, and we are going to have the block extension and the face vertices also, except for float 3. Now I'll just change this to int3s only. I'll explain why I'm using int3 here later. So for now, let's just have it as int3, and this direction is something that we can import from blocks.direction. We won't be using vertices. Okay, so we'll need to store this thing also in a separate array. Yeah. So there's a few things here, since our previous code works with managed types and now we are using this native containers, so it's a bit different. I can't directly add them, so I'll just store this into a variable here. This thing can be here, this thing can be changed, so we'll say mesh data dot triangles. That won't be a problem. It's only populating the vertex array, so for that we'll need to go into a blocks.cs and say that this thing now returns a native array of int3, and it takes in an int3. So we'll say new native array int3, and we need to give it a length which is 4 and an allocator which would be temp job, since we won't be using the result of this array anywhere else. What's this giving a problem? Cannot apply to vector 3 and int3. Yeah, so this is again vector 3s here, so we'll convert these to int3s. Yep. So now I'll explain why I'm using int3 everywhere. First of all, I'm going to have scale 1 everywhere. The reason I'm having that as an input is simply so that it is configurable, but the scale will be hard coded to 1 everywhere. I don't want to have any other scale, and the cube data that I have represents the cube of 1 unit, so all my cube positions will actually be integral points. That way I can use a smaller data type like int3 other than vector 3 or float 3 and save some memory. So that way this is good, but at the end when we are providing this to the mesh object that we need to create in Unity, we'll need to convert these int3s into vector 3. So that would be the final step of doing it, and we don't need to worry about it here. So as you can see now, this function here is properly using our native containers. Here we have this native array which again comes from the collections package, and the allocator that we are using is the temp job. Now you need to provide these native containers with the allocators. Now there are some different allocators as temp, persistence, and the temp job, and whenever you are working with the job system, you will be mostly using the temp job allocator. There will be one case when we'll be working with the burst compiler, we use the persistent allocator, but we'll deal with that when it comes. Now the temp job allocator allocates the memory for 4 frames, and if you don't free up the memory after 4 frames, currently Unity throws a warning, but in later versions it may change and you will get errors. So do keep that in mind if you're watching this video in the future. So again here we'll be removing this code here since we won't be using that anymore, and back to the cube job. So here we are getting a native array, okay, and what we need to do is take our mesh data dot vertices dot add range, so we can add a native array to this, and this will be our underscore vertices, and this count can be changed to length. So now our create phase function is also properly using the native containers, so that won't be a problem. And here we'll have that for loop which runs from 1 to 6, and it basically calls create phase for direction, which will be casted from the I value, and the position would be in 3.0, since we want our cube to be created on the origin. So with this we have our job actually done. So this job doesn't have any input, but later we will, since everything is fixed, we can actually have this position as an input. And yeah, let's just do that. That way I'll be able to show you both inputs and outputs. So we'll declare a public int 3 called position. This would be again get set, and this is what would be passed here. Okay, and with this we have a job done, and we are calling one external function which is technically not part of this job, and there will be warnings, but I'll explain it to you why. Back to our cube component, what we need to do is, we don't need this anymore, so we can remove these, and we'll be populating this in a different way. So we create a var here, mesh data. This should be equal to new mesh data, and do use the cube job one, not the unity engine.mesh. Okay, and we'll need to provide it two native lists, so we'll be creating those native lists also. Var vertices, this should be a native list of int 3 using the allocator.temp. Now for the cube we do know the length, but when we'll be creating voxel chunks, the length of these lists won't be known to us at compile time, so we'll just use the temp job allocator here. So as you can see, there are different types of allocators here, but the one that you need to be, the three most important ones will be persistent, temp, and the temp job. Actually the temp is also not used many times, it's the temp job and the persistent one only. So with this here, what's it saying? It's not valid at this point. What do you mean by that? Oh, I did add the new keyword. Yeah, and triangles equal to new native list of type integers. Again we'll use the allocator.temp job, and we'll be passing this here. So vertices would be underscore vertices, triangles would be underscore triangles, and next we'll create the job actually. So our cube job is equal to new cube job, we'll be populating it also. So the position would be in 3.0. Now you can provide any position you want here, and the mesh data would be mesh data. We can actually inline these. Yeah, let's inline them. We don't need them to be separate, since anyway we are going to change that code there. Okay, next, once the job is created, you need to schedule that job. So we'll call cube job dot schedule, and this returns us a job handle. I don't know, some import error there. So we'll store the job handle here, var job handle, and finally we need to call the complete on the job handle, complete. Now this isn't the proper way to do multi-threading, since we are scheduling it and completing it as soon as it's scheduled, so we are not allowing it to run on a separate thread. Well, technically it's running on a separate thread, but we are not actually taking the benefit of parallel processing here. But for now, this example is sufficient enough to show you how jobs work and how you can create your jobs. When we'll be implementing the proper voxel job, we'll be using a bit of parallel processing, but then there is something which the job system isn't designed to tackle, and I'll be going over what is the true purpose of the job system that I figured out from searching over the forums and everything. But that's something for the later video. And for now, we need to populate the mesh vertices and the triangles. Now the vertices expects a vector 3 array and the triangles expects an integer array, and what we have are native lists. So what we do here is a bit of link. We'll be using the C# links features. So we'll say our mesh data dot vertices dot to list. Okay, so this will convert the native list to a list. Then we'll say map, or for each, what was the map thing, select, yeah, into a new form. So we'll take a vertex and we'll be returning a new vector 3 using vertex dot x, vertex dot y, and vertex dot z. With this we have a list of vector 3's, and finally we'll call to array. So all this expression, this is using the C# link features. So till here we have a native list of integer int 3's. Then we convert the native list to a C#, the generic list class, so we get an IEnumerable. Then we call the select function, in which we'll take each of the vertex, and I have not written this properly. So basically the select function is kind of like a mapping. So we take an integer 3 vertex and return a vector 3. So each of the element of the list is now converted to a vector 3. And finally, here after this select statement, we have a list of vector 3's and we call a to array on it. So we have an array of vector 3's. And with that, it's basically done. For the triangles, it's a bit easier. We'll take the mesh data dot triangles and we can directly call to array, since we don't need to do any mappings. So this select statement can't be called directly an array, that's why we need to convert it to a list. Okay, and with this our job code is completed. We are now creating a cube on a separate thread. So if I just run this code, it may fail, I don't know, there could be errors, there could be warnings. So let's just see. At least there are no compiler errors. So interplay mode, and there were errors. What was the error? Yeah, we have not disposed them. So after the job is completed and after we have done this, we need to do mesh data dot vertices dot dispose and mesh data dot triangles dot dispose. So whenever you are using these native containers, disposing them is also something that you have to do manually. So once their purpose is finished, you need to dispose them. So let's try this again. I think there were some other errors also. It's saying the link should work. I don't know why the link is giving an error. It's saying the enumerable on native list is not working. Okay, I'll tackle this. Yeah, so I looked into it, and if you actually go and see the implementation of native lists and search for enumerable, the native list hasn't implemented the get enumerator method. It's simply throws an exception here, so we can't use the toList thing here. And in my actual code that I had done previously, it is toArray, and toArray is available for us to use. So I was wrong in the fact that select could be called on toArray only. Select could be called on a list only. It is applicable on arrays only, but what select returns us is an enumerable, so we need to convert it back to an array again, because if I remove this, rider will throw me an error. So here we need to have toArray again. Now there may be a more optimized way to convert this, but this is more elegant. I can do this in one line. And also in the cube job, where we have done, when we are done with the vertices, we can call vertices dot dispose here also. Okay, so it should work now. It may throw errors now also, you never know. That's the thing with the preview packages. So let's start. It's again throwing us an error. And what's it saying? Jobs can only create temp memory. That's a weird error. At which position this is coming at? 54. Okay, so you're saying this needs to be a temp. Okay, we'll try that. I guess this changed from a previous implementation. If I take a look back on my current implementation, and if I go to my job on my second screen, no, yeah, I'm using allocator.temp here also. Okay, so inside the job, if you are creating native containers, you need to do allocator temp. You can't use that allocator there, I guess. And it's just created one face, so that's great. We need to see why only one face is being created. That's something good. Why is only one face being created? So if I take, should run 6 times. Yeah. So I got why it created one face. If I look back into my cube job, and if we take a look at this triangles, how these triangles are coming, we are basically taking the length of the vertices array. Now vertices array will always be of length 4, so the triangles are not being added properly. What we need to do here is, instead of this, we need to say mesh data dot vertices dot length. So this will give us the proper vertex count and not that. So that means we can dispose this of before, and you can even run this without disposing it, but let's see. So there were too many errors made in this video. But that basically goes to show you everybody makes mistakes, and it's actually good. You can see a bit of the debugging process also, though I didn't show any debugging process. I mostly cut it out, but yeah. So with that, you can see our cube has been created and it's using the job system. Now the job system is not being properly used, for one thing. There are problems the way we are using the job system, and that is because our jobs are accessing external data, and you may ask where they are accessing external data or the data that doesn't belong to a job, and that's within our get face vertices function. We are using the block data, which is defined as static variables. Now when I created my voxel engine, which is shown in the introduction video also, you when you actually implement the burst compiler in this, you won't be able to access these static variables, because, and also in the later versions of the job system, this accessing such static variables may be removed and an error may be thrown, and that is a bit like, this thing can't be optimized, and it comes in the realm of managed types, and it's a bit confusing. You can go over the forums and see why this thing is not good, and that leads to another problem is there is no way we can define constant data for our jobs, and that is the problem that I'm still struggling for. The only method that I found is passing that constant data also to the job while the creation of the job. So that is something that we'll be looking in on the next video. We'll try to add the burst compiler back to this cube job and see what errors we get. And you may even, I have to check, like I was expecting a warning here to indicate that I'm accessing some static data outside of the job, but that warning isn't coming anymore. Maybe the new jobs package, something has changed, so I'll look into that also, because I was really expecting warning there so I could show you what I meant with accessing the static data. So that's it for this video. In the next video we'll be implementing the burst compiler on this job, so that would be a pretty small video because there is nothing much we have to do from the programmatical side to implement burst compiler. But with this we'll get our base ready, and then we can go ahead and do all our amazing stuff of creating voxel chunks. So if you have any suggestions, please do leave them down below in the comments. I know there were many errors in this video, but I wanted to show you those errors. Everything isn't perfect anyway, and do share it with your friends and subscribe for the upcoming videos. Thanks for watching. Bye.